What if time wasn't just a ticking clock and space wasn't just an empty void? What if they were deeply intertwined, forming the very fabric of our reality? Welcome to the fascinating concept of the time-space continuum, a cornerstone of modern physics that forever changed how we see the universe. This isn't just theoretical jargon, it's the key to understanding black holes, time travel, and even the nature of existence itself. So what is the time-space continuum? And why is it one of the most mind-blowing ideas in science? Let's dive in and uncover its mysteries. The idea of the time-space continuum was introduced by Albert Einstein in his revolutionary theory of relativity. Before Einstein, time and space were thought of as separate entities. Time was seen as a constant, marching forward unchanging and universal, while space was the infinite, unalterable stage on which the universe unfolded. But Einstein shattered this perspective. He showed us that time and space are not separate at all. Instead, they're interwoven into a single four-dimensional fabric called space-time. And here's the twist. This fabric is dynamic. It bends, stretches, and even ripples depending on the presence and motion of matter and energy. Think of space-time as a vast, flexible sheet. When a massive object like the sun rests on it, the fabric dips and curves around the object. This curvature is what we experience as gravity. Imagine rolling a marble across that sheet. It will naturally spiral toward the dip caused by the sun. The Earth's orbit around the sun isn't because of a pulling force, it's because the Earth is following the curved path in the warped fabric of space-time. This elegant idea transformed our understanding of gravity, no longer as a mysterious force but as the natural result of space-time's geometry. But space-time doesn't just warp, it also stretches and compresses time itself. This leads to one of the most mind-bending phenomena, time dilation. The flow of time changes depending on your speed and proximity to a massive object. For example, astronauts aboard the International Space Station are moving so fast and are slightly farther from Earth's gravity than we are on the ground, so time moves slightly slower for them. It's a tiny difference, but it's measurable and has been proven. Without accounting for this, technologies like GPS wouldn't function correctly. That's right, Einstein's theories aren't just abstract concepts, they impact the way we navigate our world every day. Now let's talk about the ultimate sci-fi dream, wormholes. If space-time can bend and curve, could it fold? A wormhole is a theoretical shortcut through space-time, connecting two distant points instantly. Think of it as a tunnel carved through the fabric of reality itself. If wormholes exist, and that's a big if, they could revolutionize our understanding of travel, making interstellar journeys possible within a human lifetime. Even more astonishing is the idea that wormholes might allow for time travel, creating a bridge between different points in time. However, there's a catch: wormholes would require exotic matter with negative energy to stay open, and so far such materials remain hypothetical. Still, the very possibility invites us to imagine the unimaginable. The time-space continuum also holds clues about the universe's birth and its ultimate fate. The Big Bang wasn't just the start of matter and energy, it was the beginning of space-time itself. Before the Big Bang there was no before. Time and space came into existence in that moment, expanding outward to form the cosmos we see today. And this expansion is accelerating, driven by an enigmatic force called dark energy. If this expansion continues unchecked, space-time could stretch so far that galaxies, stars, and even atoms themselves are torn apart in an event known as the Big Rip. Alternatively, the universe might slow down, reverse, and collapse into a singularity, ending in a big crunch. The time-space continuum reminds us that reality is far more complex, dynamic, and interconnected than it seems. So where does humanity fit in this vast tapestry? We are explorers standing on the edge of the unknown. The time-space continuum is a reminder of how much we've learned, and how much we still don't know. As we continue to push the boundaries of science, the possibilities are as infinite as space-time itself. Stay curious, subscribe, and join us as we venture further into the wonders of the universe.